Okay, guys. So tonight today we're gonna talk about a couple terms in probability that you may or may not have heard before. So our first pair of terms, and these are going to come in pairs because the terms are going to be opposites of each other. So our first pair of terms are mutually exclusive and overlapping. So we're going to talk about each of these terms and what they mean and an example. So mutually exclusive events are things that cannot happen at the same time. So a great example of this is when you're flipping a coin, you cannot get heads and tails at the same time. Okay, so what we would think about here is that flipping heads and flipping tails are what we call mutually exclusive, because the probability of getting event A and event B, which in this case is getting heads and tails on the same flip, is zero. There's no way to do that, right? So you can't actually flip a coin and get heads and tails at the same time. Now, some of you are already thinking, well, I could flip the coin twice and I could get heads on the first flip and tails on the second flip. That's true. It's not what I'm talking about here. I'm talking about the event getting heads on that first flip and getting tails on that first flip. There's no way that both can happen at the same time. Now we're going to look at the other term here, which is called overlapping events. Overlapping events can happen at the same time. So these are trickier to come up with examples for, but I'm going to try anyway. So let's say you roll 2 dice, okay? And one event is that the total is even. So you roll the 2 dice and maybe you get, a 2, 4, 6, 8, 10, or 12. Okay? Now another possible outcome is that the total is divisible by 5. And I'm going to go off the circle a little bit, but that's fine. So here you could roll either a total of 5 or a total of 10 on those 2 dice, and those would both be divisible by 5. Now, the reason I say these two are overlapping is that if you roll 10, you actually have an even total and a total that's divisible by 5. So both those events can happen at the same time. Now, not every even roll is going to be a 10, and not every divisible by 5 roll is going to be a 10. But there is a way that both can happen at the same time. So what I'm going to say for this one is that the P of A and B does not equal 0. By the way, whenever I write a P, that means the probability of the stuff, right? And refers to them both happening at the same time, which is possible with an overlapping event and impossible with a mutually exclusive event. Okay, so we've now talked about mutually exclusive and overlapping events. And that was one of our pairs of words. And now we're going to talk about a totally different pair of words. So I don't want you guys trying to cross-pollinate these. You wouldn't say mutually exclusive and then dependent events. This is a different set of words. They are a different pair of opposites, but they are still opposites. So let's talk about them. First word we've got is independent. Now, a lot of you probably think of independent as either the Declaration of Independence comes to mind or being able to live on your own comes to mind, right? These are independent ideas. But in probability, independent means the second thing does not depend on the first, okay? So let's imagine that you flip 2 coins, okay? So here's your first flip, and here's your second flip. Now, I'm going to make the claim, and this is actually true, that whatever happens on the first flip, whether it's a heads or a tails, it does not affect what happens on the second flip, because a coin flip always has a 50-50 chance, meaning that there's a 50% chance of heads and a 50% chance of tails. If you disagree with that, feel free to put a comment below. I'm already expecting some tails conspiracy theorists, but generally it's accepted that a coin flip is totally random, meaning that each flip has the same chance of getting heads or getting tails. I want to talk about dependent events, and these are often really hard to think about. But dependent events are cases where the second event, the probability actually changes after whatever happens in the first event. Okay, so let's say our first event is rolling one die. Okay, and then we're not going to pick that die up. We're just going to roll another die, and we're going to add them together. Now I'm going to conceptualize my first event as rolling a 5, and my second event is going to be the 2 dice totaling a 3. Now, I want you guys to imagine that you roll one die and it's a 5. What do you have to roll on the second die to get a 3, to get a total of 3? If you're thinking, hey, wait a minute, I can't do that without negative die numbers, you're totally correct. There's actually a 0% chance that if you roll a 5 on the first die, you're going to be able to come up with a total of 3. It's just not going to happen, right? There are no negative numbers on dice. So what we're seeing here is a great example of dependent events, because the probability of event B, meaning getting a total of 3, is 0% only because event A was more than 2, right? The first die was greater than a 2. By the way, I'm saying greater than 2 because the first die either has to be a 2 or a 1 to be able to roll a total of only 3, right? Because if you roll a 2 first, you can roll a 1 second. And if you roll a 1 first, you can roll a 2 second. That kind of builds on what we were talking about the other day with all the dice rolls. So this should introduce you to the concepts of independence and dependence in probability.